Okay, so for those who did not see the previous video, let me explain what we're accomplishing here. We have an equation, and we've talked about all year how that equation, if you use a calculator, you can generate a graph of that equation. It's just a bunch of xy pairs. So what I want you to do is I want you to pretend, because it really doesn't matter what the graph looks like. That doesn't change the concept. So I want you to pretend that the graph you see on the board is the graph of the function described in problem 11. It's not, just pretend that it is. What we are trying to accomplish in this unit, like every single problem you solve in this unit has one purpose. So this is like the easiest unit to understand in the entire year, because it's one simple idea. You have a function like this. We're trying to figure out, here we have a formula for how to find all the xy pairs. We want to create a new formula. The new formula we're trying to create is dy dx. And as you learned in Unit 1, dy dx represents the tangent slope of this formula. So we're going to get a new formula. It will look like this. Let's see. It's going to be negative 6x squared. Okay, so we're going to create a new formula that will look like this. And that formula can be used to find the tangent slope of this function at any point. That's the purpose of this entire unit. So far you have in your hands, you have a buff sheet that has 20 assigned problems. Your goal for each of those problems is exactly the same. Start with a formula for finding the xy pairs of a function. Create a new formula that can find the tangent slope of that function at any point. You have a pink packet. There are 30 problems in the pink. Exact same goal for all 30 of those. Questions about where we're headed? Cool. How we accomplish that is, in reality, what we would do is we would say for this graph, we're going to go to each and every point on this graph, like just point by point. So this A is just moving to different points. We're going to go to every point on this graph, and at every point we're going to create slopes to left and right. So here's a slope to the left, here's a slope to the right. We're going to make those slopes really, really short. So I'll move this point back to where it was, approximately. Come on. It's like close enough. So when we zoom in, what we do is we make those slopes really, really short. So we get a picture something like that. Once the slopes are really, really short, it becomes possible for us to see that if we could somehow make this point here become even closer, we would end up with a slope that appears to be 10, because it would be between those two secants. Okay? We want to do that for every single point on this function, so we can find the slope at every single point. That's a very tedious and time-consuming process. So long ago, some mathematicians came up with that shortcut sheet that I just handed you, that sheet of rules. The rules make it possible to, instead of going point by point and finding the slope, they create a way to find a formula that will do the same thing. So this formula will find the slope at any point on this function. It doesn't seem like we're doing the same thing. Like here we're doing secant slopes. Here we're just using formulas. But it really is exactly the same thing. In a college class, they will spend a couple of days, 2 or 3, showing you how to get from this to this, right here. AP Calculus doesn't really test you much on that, so I don't think it's worth 3 days to help you understand how to get between the two. So we just skip the middle, go right to how to use the formulas. Okay? So here's how you use the formulas. And this is where you have to use the right notation. So make sure you're writing exactly what I write. First thing you want to write on your white paper is write down the problem. Don't skip that step. It tends to lead to a lot of mistakes. So just write down the problem, like so. Next step is you simply declare what you're trying to find. I'm trying to find a formula for dy dx. So I'm going to write on my paper dy dx. Questions? And make sure that the process makes sense. For Unit 2, we don't ever learn a new process. Like the process you learned today is the process for Unit 2. All that we do in Unit 2 is keep having you practice with functions that have twists and get a little harder. That's all. Okay, next thing, we take advantage of the most important symbol in the class. That one. Equal means these two things are the same. So up here it says y is exactly the same as this. That means if I write dy dx, there's no difference if I write d of this over dx. So that's the next line. Question? Abby, please.
Explain that again.
4 points for Abby. So just explaining again, it's all about this. So are you comfortable, and if you're not, just say no, it's no big deal. Are you comfortable that the goal here is to create this equation for dy dx? Good. So I start out the problem by simply stating what I want to find. I want to find dy dx. So I just write it down. Then what I notice is the symbol y is exactly the same thing as this expression. So all I really did is I replaced y with y's equivalent. And so that's why these are equal, is because I've got dx on the bottom, I've got dx on the bottom. Here I have a d, here I have a d, here I have y. Oh, this is also y. It's just a different version of y. Does that help? 4 points. Megan. Say again, Megan.
Does it need to have parentheses or anything?
Awesome question. 4 points for Megan. And I think I mentioned I'm upping the points because I only see you half as often. So whenever you have a fraction bar like this, that's considered a grouping symbol. It's a way of like saying these things go together. I put the d here. It's d of all of it. It's actually optional. You can do it either way. If I had this, though, if I had d of negative tangent, I would definitely put parentheses because it kind of looks like I'm subtracting. This one, either way is fine. Does that answer your question? Let's go here.
Why does the 2x3 on the second part not have a negative?
Please show me your hand. So the question is why there's not a negative here. Please raise your hand if you noticed that mistake. 4 points, 5 for Gracie. Yeah, just my bad. Sorry. Anybody else? Please.
When you notate, instead of writing dy with dx every time, can you write y prime?
So Ella remembered something from the first unit, which is dy dx and y prime are the same thing. So what you'll see me doing at the board is I'll kind of switch back and forth because I want to prepare you for a test question that they may use either symbol. For your work, whichever you like better is fine. So yes, y prime is totally fine. 4 points. Awesome. Okay, next thing. It's important that you be very comfortable with the fact that our goal was to find a formula for dy dx. And we actually have found that formula. It's right here. D over dx of that thing. If we have a computer, we're done. There's nothing else to do. Just tell the computer to do that. It knows what to do with that ddx operator. However, half the AP test, actually 2/3, is no calculator. So they expect you to understand how to get a formula that is more useful. A formula that doesn't have this ddx operator in it. That's what the rule sheet is for. It's how we transform that box in blue into this answer over here. That's what we're trying to figure out. Notice there's no ddx here. So the goal is to get rid of ddx. Like the ddx is fine if you have a computer, just without a computer you can't really do anything with it. Questions? All right, cool. Here's how we get rid of it. Go to the rule sheet. We must find the appropriate rule that fits our given situation. You will use typically a different rule to begin each problem, because each problem has a slight difference. You've got to find the rule that fits. So this one, not too bad. It's right here, inverse tangent. So I'm going to copy that over so it's a little easier for us to see it. Notice as I'm copying that the inverse tangent rule contains a symbol g of x. Part of your work is to figure out what must you identify g of x as being in order to make a perfect match. We want the blue box to match this pink box. And it must be a perfect match, no difference whatsoever. The way I get them to match is I get to pick g. So g of x, in this case, must be negative 2x cubed. As long as I make the correct selection of if I pick the right rule, and I pick the right g, I can make them match every single time. Please, Adam.
So the g of x is just whatever goes after the tangent of the first box.
In this case, the g of x will have a slightly different meaning in other situations. We'll show that in a second. But you are correct. To get the inverse tangent rule to match, first I've got to make sure I pick the right rule. So everything's great as long as I choose g to be negative 2x cubed. Then they are a perfect match. 4 points. Anybody else? Okay, cool. So now all you do is you again use the most important symbol in the class, equal. You say, well, if the blue box is the same as the pink, so this blue box is exactly the same as this pink box, as long as I choose this for my g of x, then I should be able to take advantage of this equal sign and take this green box and put it in place of the blue. That's what I'm going to do. Questions? So let me move some things out of the way here. It's not the button I wanted, but try again. Okay, we're going to use the green box now. So we write y prime equals 1 over 1 plus g of x. Here's g of x. So negative 2x cubed all squared multiplied by d over dx of g. I'm simply following the rule. Question? Oh, please.
What, can you explain why the green box equals the blue box?
No, perfect, Ellie. So Ellie's question was, how do I know that I can replace this blue box with this green box? Is that correct, Ellie? It's actually a sequence of things, Ellie. I first figured out that the blue is actually the same as the pink. Are you okay with that? Can you see that they're the same? And then the rule tells me that the pink and the green are the same. Therefore, the blue and the green must be the same.
Okay, so then when it's like g of x, you just plug in the negative 2x.
Right. The only way I can make, okay, so once again, the only way I can make the blue exactly the same as the pink is by selecting g of x to be negative 2x cubed. Once I've made that selection, I now have forced the green box to be exactly the same as the blue, as long as I again use g of x negative 2x cubed. Did that answer your question?
Yeah.
4 points. Okay, so we wrote it down. Something else you all should notice. This process is very much like the movie Inception. It seems like most people have still seen that movie, even though it's a few years old now. You start out applying the DDX operator right here. DDX is applied to all of the function. All of it. Okay? Then you use a rule. We use the inverse tangent rule. As we use the rule, what happens is a portion of our final result is revealed. Notice how there's no DDX operator on that piece. So that part's done. But there's still a DDX operator. But the DDX operator is now only operating on a portion of the original function. It's like Inception. We're starting on the outside, we're working our way down through the function. Questions? Cool. The nice thing about this process is now you just repeat the process. Just start over. You say, okay, this part's done. I just need to focus here. So I've got to go find a new rule that fits that situation. So you set this rule aside. We're done with it. It also means we don't worry about g of x anymore because we've used that rule. We go grab another rule. The next rule we grab is probably the most used rule of all of them. Oh yeah, please, Bennett.
When you simplify it to the next one, like, would it matter if you chose the power rule or the multiplication rule?
Gotcha. You technically must pick the multiplication rule.
Okay.
If you pick the power rule, you're actually going to make a mistake because the power rule allows for a situation where you have some expression. Let me get right pen here. So Bennett's asking, do I have to pick the multiplying constant rule, or could I pick the power rule? The reason the power rule won't work is the power rule is only designed for when you have something to some number.
Okay.
And in our situation, we don't have that. We have -2 multiplied by something to a number. So I have to use the multiplying constant.
Makes sense.
You good?
Yeah.
4 points. So the multiplying constant rule is the easiest one to remember because all you do is rewrite this entire line. Make sure you write out the entire line. Don't use ditto marks. If you use ditto marks, it's like you stamping your page saying, yep, I am not going to retake no matter how bad my test score because I'm not using the right notation. So that's my failed attempt at sarcasm. So anyway. I don't know, for whatever reason, like sarcasm, I always feel like I'm just being mean when I'm sarcastic. I can't do it. Like I try and then like halfway through, I'm like, oh, this isn't working. I confess I'm trying to be sarcastic, sorry. Okay. All you do is pull out the -2. Don't forget the parentheses. We've got to make sure we know we're multiplying. If you leave out the parentheses, you're going to cause a mistake. So that's the multiplying constant rule. You just pull out the constant. Okay? Just make sure you can only pull out multiplying constants. That's why it's called the multiplying constant rule. So, yeah. Oh, please.
Why'd you pull out -2 for that? Is it because -2 is A?
Yes, perfect. Perfect. 4 points for Ellie. So Ellie asked the question, let me get the rule on the board, Ellie. Like, why did I do what I did? And what I was doing is using the multiplying constant rule, which I'm going to copy over right now. Paste that in. It's exactly what you said, Ellie. Where'd it go? Paste. There it is. So I look here, and I've got to make sure, just like we did on the last one, that I have an exact match. So here's my blue box. This box must match exactly with this red box here. And what I do to make sure they match is I identify A is going to be -2, and f of x is going to be x cubed. Does that answer your question? You okay?
Yeah.
Okay, 4 points. Please, Jake.
Did you also use the power rule?
Let me put the power rule on the board. So Jake's question, somebody said it on the videos. I forget to repeat the question, and they can't hear it. So if I sound redundant, I'm just trying to help them. So Jake said, why can't we use the power rule? Let's copy it over. I'll show you. This actually fits with Ellie's question. 2 more for Ellie. The whole idea of how do I know the rules actually match? Here's how I know. Back to here. Okay, drag that down. You notice, I've got the blue box right here. I want that blue box to match this. All I get to pick is g of x and n. So I've got to make the blue and the orange match. But I only get to pick g of x and I only get to pick n. Somebody would like 4 points, raise your hand and tell me what should I pick as g of x to make them match. Let's go, Abby. Interesting thought. I actually could do that. I could say this is -2x to the third. Stay with me, Abby. What would you pick as n? What's again?
So it would be just -2x, and then it would be.
N would be 3. That's what most people think. It really is normal thought, is to do this. 4 points for, actually take 8, Abby. This is a good conversation. Put down 10, round it off. So what Abby said was -2, correct, Abby?
Yeah.
And then 3 here. The mistake is we misread it. We think -2x cubed means -2x being cubed. Like that? It's not. It's really -2 all by itself multiplied by x cubed. So that's why the power rule actually doesn't fit. Because we've got this extra constant, which is not a part of the power rule. Does that answer your question?
Yeah.
Good. Anybody else? Jake, sorry.
So the power rule is the one you use after you use
Perfect. So I've used the multiplying constant rule. Jake said, oh, now I'm going to use the power rule. Because right here, this pink box, Jake, what would g of x be to make the pink box match the orange box?
G of x would just be x and n would be 3.
There we go. G of x is simply x, n is now 3. Now I have a perfect match. So we did use the multiplying constant rule first. Now we're going to use the power rule. Question. Please.
Does that will usually happen if there's like an exponent but it's not
for both of them, or you just need to multiply and then power?
It's actually extremely common.
Okay.
What Megan said was, is it really common to use the multiplying constant rule first, followed by the power rule? It's not like always, but it's really common. Here are some situations. If we see that, we have to use the multiplying constant rule first, because Megan, what's the multiplying constant? Anybody know what's the multiplying constant here?
The -1.
It's -1. This is really -1 multiplied by x to the 4th. So you'll have to use the multiplying constant first, then the power rule. Is that what you meant? 4 points for you and also for Michaela. Question? Cool. Let me erase some of this. Compliments to all of you. You're asking the right questions. Like, you're doing a really good job of not just kind of copying my steps, but thinking about, like, why is he doing, you're doing this. Like, why am I choosing to make the choice I made? It's perfect. Just keep doing that. Got to get some erasing going on here. Move some stuff out of the way here. Okay, next line. Y prime, or back to dy dx. It doesn't matter which. 1 over 1 plus. Okay, now you have to remember what it means to square something. We're not doing calculus here, we're just doing algebra. This says -2x cubed squared. That means -2x cubed multiplied by -2x cubed. Which means you've got a -2, you've got x times x times x, and then you've got the whole thing again. And all of those things are being multiplied together. That's not what I meant to write. Like that. You multiply them in any order you want, so I put the 2's together, that gives me 4, and then I get x to the 6th, like that. Question? So I'm going to write 1 plus 4x to the 6th. I've still got -2. Now I have to use the power rule. Well, here's the power rule. Oops. My g of x is just x, my n is 3. So I have to write down 3. Put 3 in parentheses so you don't make a mistake in thinking you're adding. That's the n. G of x is just x. And -1 is 3 subtract 1. Now I have d over dx of g of x, which is just x. Like that. Question? Oh, please, Grace.
So is there ever a time where you don't simplify what's on the bottom, like the 4x to the 6th? Because I know you do it in a square root, but do you ever, I don't know how to...
Your question's right on track, Grace. It really is. You're asking, here I took and said, I'm going to multiply that out by squaring it. There is absolutely no requirement on the AP test that you ever do that.
Okay.
I only did it because I'm cheating. Like, I kind of knew the answers, had all done that, so I had to find an answer. But it's not required. Does that answer your question?
Yeah, on the AP test I don't need to simplify?
No. If it's multiple choice, you have to find your answer, so you might have to. If it's on the written section, you don't have to, and I wouldn't. Yeah, written section, we leave a lot of stuff just alone, don't do anything. Just because you don't have to. So, is that your question?
Yeah.
4 points. And
So when you simplified the equation with the inverse tangent rule, are there some, like, on the homework, I know there's some cases where you would add the other components. Is that true? Like,
You're talking about
you get what I'm saying? Because, like, you see how you said, like, multiply times the d parentheses negative 2x to the cube? Would in some cases, would it just be adding it if you did different rules?
So Bennett's asking here on this line, I've got this being multiplied with this, right?
Yeah.
And you're saying in some of the cases on the buff homework, you notice that you'd have stuff being added. It just depends on what you start with.
Okay.
So yeah, there are examples on the buff where you end up two things adding.
Yeah.
Usually that's when you're using the add subtract rule.
Okay.
So it will just vary. There's no specific pattern necessarily. That makes sense?
Yeah, that makes
4
sense.
points. Somebody else had their hand up. Megan.
For the test for this unit, are we going to have all of the rules memorized?
Yeah, the AP test, there's no notes allowed. And so I have to get you to memorize them as quick as possible.
Okay.
It intimidates everyone every year. Like they see that list and they're like, how in the world am I supposed to memorize that? Fair. Yeah, it looks impossible. I promise you, never in 14 years have I ever had a single student do poorly on test 2 because they couldn't memorize this. If you just stay with me on the homework, you use my notation, most of the rules kind of just get memorized through practice. And then the ones that are a little bit different, that even I have to look up every single year and go, I'm serious. Like I have to go, okay, wait a minute, I've done this for 6 months. Oh yeah, that's the rule. You know what I mean? It's really not as bad as it looks. It does look bad on the first day, it really does. So I get you. Yeah. So my reassurance, I hope, is that just from experience I've learned, it doesn't turn out to be so bad. So, okay. 4 points for Megan. Anything else here? Like it's kind of like it probably won't work perfectly, but I'm pretty sure that if you asked your sister, Laura, right?
Yeah.
This unit tends to come back to people better than the whole rest of the year. Like she'll go, oh yeah, I remember those. Like you show her the sheet, she'll go, oh yeah, I can remember most of that. She just have to review a little, but it still will stick with her. So, we good here? Cool. Okay, we're done. Because what's dx divided by dx? 1. That's it. We found a formula. Our formula does not contain a ddx operator anymore. We have a formula that can be used to compute the tangent slope of any point on that original function. So now we just kind of put it together. So fraction, this stuff's all in the numerator here. So that's going to be negative 6x squared divided by 1 plus 4x to the 6th. And like I said, the good part about Unit 2 is that's the process. Like we don't ever do anything different. We just keep learning to use different rules. That's it. So, okay. That was going to ring in like a minute, so well done. Any questions? Oh, please, great.
I have a question about another question.
Let me stop the video for a moment.